Okay, righty-ho. Let's have a wee look. So this is part 2. Now, at the end of that last one, it cut me off, but we were there, okay? I just had to say that was actually the angle that we were finding, and we were there, so that was good. All right, let's have a look at this one. See the triangle XYZ shown, and we're wanting to prove that these two lines are perpendicular to each other. So, of course, perpendicular means we're looking for 90 degrees. We need to think about ways that things become perpendicular with geometric reasoning. It basically means that those would both be right-angled triangles, doesn't it? Okay, so let's have a look at the question and what it tells us, and so what information that we know. So we know that this line XH cuts the angle YXZ, so this angle here. We know that it cuts that in half. So that's kind of cool to know, because what that means, of course, is that this angle and this angle are equal, aren't they? If that's cutting it in half, then they're the same size. Brilliant. Okay. And then we also know that we've got XYK, this guy here, being, this guy here is the same as this KYZ, yep, plus that. Okay, so if I add those two together, then I'm going to make angle Y there. I'm just putting in those little things to help give you an idea. All right, so that's what we're wanting to prove. Okay, so we know that these two are the same. Straight away, what I can actually see is that this angle here, XKY, so this yellow angle there, you know how we've got the exterior angle being the sum of the two interior angles of a triangle? And of course we get that because 180 minus that gives us this guy, and 180 minus these gives us that guy. So that means that you get them in the same way. So let's do that. So let's talk about him. So that's angle XKY. That's the same as angle, so it's the same as, you know, these two angles, you see. And that's why I'm really interested in that one, because those are the two angles adding together that what we want to know. So those two are, what are they? Angle KZY plus angle KYZ. Super interesting. Okay, and I think that's a good start. Okay, so those two, I'll just put things in colors here because I think that might help. I'm not saying that they're the same size. I'm just putting them in green, that kind of adding them together in green like that. Okay. All right. So that yellow angle, XKY, is the sum of those as well. We know that these two pink angles are the same because that line XH is bisecting them. It cuts them in half. So if they're both the same, then these triangles, no, they're not similar. Let me think. So let's have a wee look down here. What did they do next? So yes, we know them. Oh, they've done things in a slightly different order to me. Oh, yeah, of course. So we can now describe the size of our angles, can't we, in relation to these guys? So if this guy here, XKY, if he is the sum of those guys, then I could describe angle XYZ, which is the one that we're after, or XYK. So angle XYK, which is, I don't know, let's make it blue. Now, one thing that I've just noticed in the answers, they actually rename some of the angles with a little x and a little y. That's a really good idea because it saves this kind of tongue twisty X, Y, K, Y, Z, M, Q, you know, all of these jolly letters. So if you want, right at the beginning, you can say let angle XKY equal little x or little a or whatever you want to call it. You can do that, okay, so long as you explain very, very clearly that that little letter you've given it stands for this particular angle. Okay, you have to make sure you actually say that. Alrighty-o, so sorry, I just jumped ahead there and then I've just jumped back again because I've realised I did more than I needed to, which is fine because that's in this 3-hour exam you can take your time, can't you? Your 3 hours to do this. Okay, so you've got your yellow angle being the two green together, added together. Of course, we're told right at the beginning that our blue angle here, XYK, is also angle KZY plus angle KYZ. Okay, and we tend to write given, and that means that information was given to us at the beginning of like in the actual problem. So check it out. That means that those two angles are exactly the same. So if those two angles are exactly the same, then we've got an isosceles triangle there, don't we? So we can actually chuck that and that on. We know that those two pink angles are the same because this was cut in half. So therefore, each little triangle, so if I then talk about triangle XYW, that is going to have the same angles as XWK, those same triangles. They've got the same angles on the inside. They're going to have to, aren't they? And so therefore, those angles in the middle are going to have to be the same. And of course, since they're the same, they're on a straight line there. Since they are equal, we have 180 divided by 2 because they are on a straight line, which is 90 degrees. Therefore, the lines, whatever they are perpendicular. Okay, and you can write that conclusion on as well, perpendicular. Right, cool. I'm going to move on to the next one. So we've got this one with a ladder. Okay, picture showing an obstacle course, the ladder making an angle of 42 degrees with the ground. Our triangles are similar, and we've been told some bits and pieces here about, let's get you out of the way. We've been told some bits and pieces here about the measurements going on here. We want to calculate the length P of the line FD. Oh yeah, yep, cool, okay. So you'll be able to find, and I might not do all of the bits and pieces for this one, but use Pythagoras. What I would do if I was doing this, use Pythagoras to find this length here, FD. Okay, and let's go through and do it. So line FE squared is going to be 1.78 squared plus 1.6 squared. Is my calculator? Actually, it's probably just down here in the answers. Yes, they've done the same, 2.39. So FE is 2.39 meters. Lovely. Now these, we are told, are similar triangles. Okay, we're told that. Okay, so we know they're similar triangles. That's fantastic. So that means that the ratios, of one thing to the other is going to be the same either way. So we're going to compare those ratios of 2.39 to P. Okay, or actually it's probably a bit nicer if we write them the other way over. P over 2.39. So the ratio of that hypotenuse to that hypotenuse is going to be the same as the ratio of this, because remember we talk about the smallest length, the middle length. So this is the shortest length of the little triangle. This is the shortest length of the larger triangle. Let's use purple. Then your longest lengths I've done in blue there. And your middle lengths, this is the middle length of your little triangle, and this is the middle length of your larger triangle. So that's how we can compare them. The hypotenuse are always easy to compare because they're really obvious. But the other two, you've just got to be really careful for, okay? So similar triangles, this is what you want to practice for this type of question. All right, so we can compare the ratio of the hypotenuse over here to line FE, which was 2.39. That ratio is going to be the same as, look at these, we've got these two purple measurements here, so the two middle measurements, the middle one for the shortest one, which is 1.6, and what looks like, you know, we've got P on top, so our shortest one, hey love, oh yeah, we could find the CD, couldn't we? Isn't it? Yep, you can listen to that. 1.6 over 1.78. So, you know, that top line is the smaller triangle and the bottom line is the smallest, the smaller triangle, and this is for the larger triangle. Yeah, okay. So comparing the same to the other. So now in your calculator, if you do 1.6 divided by 1.78 and then times that by 2.39, okay. So just use mine. We've got 1.6 divided by 1.78 equals, and then times 2.39 equals 2.148, and we're finding a distance, so that's meters. I have a feeling that, oh, it is, wow. It's an excellence question, isn't that amazing? It's a pretty short one, but yeah, that is actually an excellence question. I thought it might have only been merit. So does that kind of make sense, hopefully? So it's the thing you've got to be super careful about is comparing the shortest with the shortest and the medium with the medium, and the longest with the longest, and making sure you've got the same triangles in the same places, okay? The smallest, as I say, on that top line there, and the largest on the bottom line. Yeah, cool. All right, thank you. So that's it for those excellence questions, and hopefully I'll see you guys tomorrow.